Hello everyone. In this video, we will be discussing part B experiments in our foundry forging and welding lab. In part B, where we will be discussing only about foundry experiments. We should be aware what you mean by foundry. As we know that when we speak about casting and even the other like the novelties making process, this foundry also plays a very important role because comparatively this is the very cheapest method of making the components, and about that too by using the sand. So we will see the introduction part in this video, and in the next video we will see the experiments which is relevant to our syllabus. Here, the molds I'll be making, particularly in the foundry, I'll be making the molds made of the sand, which is very cheap, and it is sufficiently refractory even for the steel foundry use. We need to highlight this particular line because even we can able to founder what steel materials also. In addition to the sand, a suitable bonding agent. Usually, we'll be using a clay only, which is mixed properly with the sand, so that a proper combination will be occurred, and the mixture is moistened typically with water but sometimes with other substances also to develop the strength and plasticity of the clay and to make the aggregate suitable for the molding. So we need only two sources. The first one is the clay and second one is the sand. So how exactly we are making the given with the help of the given sources, how we are converting them to the particular condition we will be discussing here. So the sand is typically contained in a system of frames. We call it as a mold boxes, which is nothing but flask. So hereafter, wherever the word flask I'll be using, we need to remember that is nothing but frames or mold boxes. So then the mold cavities and the gate systems are created by compacting the sand around the models, which is called patterns. So the mold cavity is whatever the shape we are looking for, the final like output. So that can be done with the help of your mold cavities, and how we are pouring the molten metal means through a gate system. So by carving directly into the sand or by 3D printing also is possible. So there are 6 steps in this process. First thing is we need to place a pattern in sand to create a mold, incorporate the pattern and the sand in a gating system, and later we will be removing the pattern. Once it is pattern is removed, we need to fill the mold cavity with the molten metal, allow the metal to cool naturally, break away the sand mold and removing the casting. So the same thing whatever I explained here, once again I can show it here. So this is the pattern I'm looking for. You can able to see this is the pattern I'm looking for. So this is the one half of the pattern and this is the another half of the pattern. So I want to keep this first half and the second half in this thing, and finally I'm looking for this kind of shape. So first what I'll be doing means I'll be placing the flask over the first pattern, and later once it is done means I will be filling up the sand, the mixture I said, no, the clay with the sand, that I'll be filling up with this flask. And second thing is taking the second pattern again, putting the flask over it, and again mixing up with the like the combination of sand and the clay, and I will be getting these kind of shape. So once it is done means keeping these two flasks together, you can able to see this, and I will be tightening with this, and already I will be creating the gateways, either one side or sometimes two sides also I'll be making. So you can able to see this is the assembled modes, and later with the help of the gateways I will be pouring the molten metal through these gateways, and finally it will reach it, and we will be allowing it for natural cooling process. So once it is getting, once the cooling is done, we will be removing this by breaking this sand particles that is the content, and finally we will be getting this the casting process, the solidified casting in this particular shape. So here, so patterns. So from the design which is provided by the designer, a skilled pattern maker builds a pattern of the object to be produced using wood, metal, or plastic such as expanded polystyrene. And sand can be ground, swept, or sprinkled into shape. The metal to be cast will contract during solidification, and this may be non-uniform due to uneven cooling. So therefore, the pattern must be slightly larger than the finished products. So a difference known as contraction allowance. and the different scaled rules are used for different metals because each metal and alloy contracts by an amount distinct from all others. Patterns also have core prints that create registers within the molds into which are placed sand codes. Such codes, sometimes reinforced by wires, are used to create undercut profiles and cavities which cannot be molded with a cope and drag, such as the interior passages of walls or cooling passages in engine blocks. Paths for the entrance of metal into the mold cavity constitute the runner system and into the sprue. Various feeders which maintain a good metal feed and ingates which attach the runner system to the casting cavity. Gas and steam are generated during casting exit through the permeable sand or via risers which are added either in the pattern itself or as separate pieces. And here you can able to see in our laboratory how we are following the step-by-step procedure for preparing a mold cavity. You can able to see this. Uh, you can able to see the dimensions. This is 120, this is 142, and this is 104, and this is 103. You can able to see I'm talking about the width and the thickness. You can able to see if this is a different pattern means how finally we are getting. You can able to see this once this is once it is kept, the pattern is kept, I will be filling up with some sand till this particular layer, and later I will be again going with this runner and riser pin with the help of a cope. I'll be filling up and I'll be creating the hole. I can able to see this. It will be completely merged into this particular place, and once it is properly done, I'll be waiting for some more time for the allowing that is the cooling process. So once it is done, I'll be removing this particular drags away from this one, and this is a parting line where some distance should be maintained from the runners to the riser pin. You can able to see this. So by using these kind of set only, we will be preparing the experiments in our laboratory. So we are not going to use any molten metal. So we will be just creating like the shapes of the patterns. So accordingly the same procedure can be followed to achieve any kind of shapes by using the foundry operations. So this is only for the demonstration purpose that can be done by using any shapes. We have different patterns available in our lab, and when we will be doing the experiments for all the different patterns, and the procedure remains same in the next video where I'll be explaining the methodology or the procedure to do the foundry operations. Thank you.